So I'm Glenn Oxborough, QC sales specialist with Ishida Europe. I've been with the business now for 9 years. Throughout that time I've had a number of roles, but all specialising within the quality control portfolio. My specialism over a number of years, both with my 9 years at Ishida and prior to that, has been solely around X-ray inspection. The market for X-ray is forever growing. X-ray was introduced into the market really probably around the late 1990s into the early 2000s, and since then it's really started to gain traction within the market. Started quite slowly with people looking to replace existing metal detection technology, but as time has gone on, we see more and more customers moving towards X-ray to really enhance their food safety going forward. So when X-ray was first brought into the market, it was really there to look for the detection of metals where metal detection technology wasn't able to do that effectively. So things like ready meals in foil trays, that's where X-ray found its natural home to start with. But as technology's evolved and customer requirements have evolved, we're seeing more demands from customers now to detect more and more materials that are more challenging to detect in more challenging packaging types. So some of the things that we're seeing now, really anything with a inherent foreign body risk. So anything that's got ingredients that are harvested from the fields. You know, you can imagine that as you harvest product from the fields, you can get all sorts of debris that comes up with that product that can find its way into the end product that goes to the consumer. Proteins are another key market. Proteins, you have an inherent risk of bones. Whilst packaging might say may contain small bones, that's still ultimately a complaint when it comes back, and that's found by the consumer. So now with the technology that we have available now, we're able to address more and more of those demands to find more and more of those foreign bodies. It really comes down to enhancing the food safety, both from the producer's point of view, so they can guarantee the integrity of the product that leaves their factory, but more importantly almost is for the brand owner. So whether that is the company themselves, you know, if it's their own brand. A lot of our customers though are packing for some of the major multiple retailers in the UK, but also a lot of the major fast food chains as well. And you can imagine, you know, if you're producing product for some of the major fast food chains, if they have a problem, then that's, you know, a much higher problem. And they are really pushing the levels of food safety forward and forward and forward all the time. Food safety really, at the end of the day, comes down to protecting the consumer. So whether that's a particularly high-risk product, so when we're talking about high-risk products, it's often the ready-to-eat products, so something that you will take straight from the packaging and eat fresh. If you're preparing a meal, as an example, you might take the ingredients out, and if there's a foreign body in there, okay, it's not very nice to find, but you find it before it's caused any serious harm. If it's a ready-to-eat product, you don't stand any opportunity to find that until you actually ingest it, and that can do an awful lot of damage. So it's really about protecting the consumer. We do a lot of work also, you know, looking at infant feeding. You know, if you think of the risk associated with a small child ingesting a product that perhaps has a piece of wire in it or something like that, you know, it's potentially catastrophic for the, you know, both for the child and then ultimately going forward for the producer and the brand and everything else. So yeah, it's really of critical importance to make sure that anything goes out, you know, is to the highest standards and has the minimal chance of any foreign bodies within it. We are a Japanese company. Anybody that has ever exported product to Japan will know how stringent the food safety regulations are in Japan. We bring that core technology, which we have to be at the pinnacle of to be able to compete in the Japanese tech market, in the Japanese domestic market. We bring that core technology into Europe, package it in a format that is suitable and relevant for the European market to give a robust solution for the European customer to meet the hygiene requirements, throughputs, packaging sizes, but having that core level of detection capability that we get from having that Japanese heritage. And that's really what differentiates us. It's having that level of detection packaged with an overall solution that's suitable for our European markets. So this is the IXPD from Ishida. The IXPD represents the latest technology that's available within X-ray and is really the pinnacle that is available within the marketplace today. What differentiates the IXPD from traditional X-ray systems is the way that the detection system works and operates. With a traditional X-ray system, the X-ray is generated from the top of the machine, passes through the product onto a detector underneath. But actually, when we generate the image, there's a process called scintillation. And that scintillation converts the X-ray into visible light, and the detector measures the visible light. The new IXPD is what we call photon detection or photon counting technology, which removes that stage of the process from the image generation. That gives us a number of benefits in terms of the technology. Removing that stage gives us a much clearer, sharper image, because when you convert to light first, you get some noise into the image, so it's not as defined. So we get a much more defined image. The resolution is much higher, enabling us to detect much smaller foreign bodies. And because when the photons hit the detector, we're able to measure their energy, we're also able to utilize what we call dual energy technology to enhance the detection of lower density foreign bodies as well. Where this machine really stands out is in applications such as the detection of bones in protein, primarily things like the detection of bones in chicken, where we have an existing machine there, which is our G2, which has been a very high standard for many poultry producers. This machine takes it on to the next level beyond that. But also it enables us to do things what we call complex images. So here we can see a packet of pasta. So the pasta has various shapes, different densities, overlapping, and you can see it's a very complex image, many different densities. And this is quite difficult for the machine to be able to analyze. A similar product might be something like frozen vegetables in a bag. Again, many overlapping, different densities, different shapes. Or one of the classic ones is something like French fries, frozen French fries in a bag, many overlapping, different shapes, and the chance of having a vertical fry. And if you get a vertical fry, that will often cause false positives with traditional X-ray systems as well, which can often be a problem for the end user. On the example that we have here, so here we have various foreign body types that we test the machine with. So we have stainless steel spheres, stainless steel wire. We use wire because one, wire is more commonly the type of foreign body that's going to be found in the real world rather than spheres. But also wire from a metal detection point of view is quite tricky for a metal detector. So this really shows how X-ray can differentiate from existing metal detection technology. We also have glass. Glass in itself is obviously a potentially very high risk foreign body, but also glass, because of its makeup, is a good representation for mineral stones. So if you have a product that is field harvested, you get a risk of having mineral stones within that product, and the glass test sample is a really good indicator for the level of stone that you'll be able to pick up. And finally, we have an EDPM rubber. The rubber is much lower density, but in many processes there are rubber sealing compounds and rubber O-rings. So again, it's often a foreign body that people need and want to be able to find. So what we see here, we have 5 stainless steel samples, which is getting us down to 0.4 millimeters stainless steel detection, very, very small. The wire is even more impressive. At a 5mm length, we're down to a 0.3mm diameter. And here is where the dual energy kicks in. And this is where we get really impressive. Because for these foreign bodies here, we can't even visually determine them on the image, but the machine knows they're there. So in terms of the glass samples, we're down to 1.5mm glass, and the rubber, we can't differentiate at all, but we're actually down to a 3mm rubber. So in an overlapping and complex image like that, that is the pinnacle of what you're able to achieve with the latest technology with X-ray. So what enables the machine to be able to achieve what we can achieve? Well, one, as we've discussed, is the photon counting technology that is employed within the machine, but also integrated into the system are what we refer to as the Ishida GAs. And the GAs are the genetic algorithms. And that is really unique to Ishida. That allows you to tune the machine to be specific to your product and the foreign body that you want to be able to find. For every challenge, there's Ishida.